cold, suffering. So we're right in town, well close. So that's kind of what we do here with our volunteer crew. We're open, like for these special public star nights, once a month. Except for December, next week, Friday, we have a second one. And John is going to talk about the Star of Bethlehem then. What was that? What was the scientific explanation for that? What was the coincidence of planets, stars, whatever? And when was it, right? Really important. Was it the year zero or was it not the year zero? So that'll be next Friday night, a short talk, half hour, 45-minute talk. Okay. We also are open by appointment every or any night or day of the year. As long as you go on our website and make an appointment, or with a volunteer or two in here to help you with the telescope. It's your evening, it's only your group here. And you bring clear skies, we'll do the rest. That's kind of how it goes. We're also happy to report that since we opened in 1999, we're now very close to our 50,000 visitor here, with about 68 to 70% K through 12 age group. So that's our target audience, so we're pretty happy about that. And the building has been built by a crew of volunteers. Originally, it was only one dome and a smaller room. 2005, 2006, we expanded it for a second telescope. We're still working on the second telescope. It's still not done. You probably heard me say this many months now. I'm probably just as frustrated as other people, but one of these days we'll get it done. And we'll look through the old NASA telescope that was used in the Apollo program, which is behind this wall. So after the talk, I'm more than willing to show you the telescope for you, those of you who haven't seen it yet. It's a 24-inch. It's a good-sized telescope that was used at Mount Wilson near Pasadena, California, to figure out if the moon was a hard surface or a very soft, dusty surface. NASA didn't want to have a public relations disaster that the astronauts would disappear in a cloud of dust, never to be seen again. Didn't happen, so the telescope did its work and figured out it was a hard surface. And then they picked the landing spots with that telescope. So it's pretty historical, pretty interesting that we got it here in Little Bertha, the center of the universe, of course. Right? So anyway, that's kind of what we do. We want to do outreach to the community. We're open on special occasions, and typically not for meteor showers, because the meteors are just too large apart in the sky. You can't see them very well with telescopes. It's much better to lay back in the grass or on an easy chair and look up and see the little meteorites or little grains of sand come into the atmosphere. That's basically what they are. They're little ones, not much bigger than a grain of sand, maybe a grain of rice. And what you see is not the burning up of this little piece, but ionization in the upper atmosphere. So that's what makes the trail, basically. Lots of ionization up there because of speed. Right, Professor? Friction. Friction, yes.
So the organs are hitting the...
And we thought space was cold.
That's right.
Right?
It's until you find a planet.
Yes. So that's kind of what we do here. We're always looking for volunteers. So if anybody wants to come in and volunteer here, play with the telescopes, we'll teach you. Sign up on the website, starkids.org, and we'll make you part of the crew and put you to work. There's some cleaning jobs, bathrooms, vacuuming. I mean, there's all kinds of chores here, and as reward you can play with the telescopes. That's kind of how it works here. Anyway, tonight we're very happy to have John Ensworth talk to us about Are We Alone? John is a very interesting gentleman. He reviews a lot of NASA publications for age appropriateness for school, for students. He works throughout the whole country. Has run observatories, planetaria, has done lots of teaching, and he did, half a year ago, the theory of everything, presentations here, basically predicting the Higgs boson, which the Large Hadron Collider is trying to find and tantalizingly close. And tonight, hopefully, it will be a little less academic. Is it fun?
Yes.
Okay, good. Are you going to tell us the answer beforehand? No. Okay, so with that, John, here is your floor.
tonight. So let's start off with this. What is life? Who can answer that? All right.
Something that can reproduce itself.
Something that can reproduce. Okay. Anything else? You need to be alive? Look alive, people. Breathing, okay, so respiration, taking in material from the world around you, that's good. How about one more thing, anything else? Thinking, okay, that's intelligent life, yeah. All right, so are animals alive? Yeah, okay. How about plants? Happy with that, okay. They don't do as much as animals though, but they're still alive, okay. How about bacteria? Yeah, okay. How about viruses? Oh, it's iffy. Yeah. We'll look at viruses just in a moment here. How about something called prions? This is what causes mad cow disease. The misfolded proteins, they can pass around from creature to creature like a virus. They reproduce inside the brain and do horrible things. Think that might be alive? I knew I was going to hit a boundary here someplace on you. So let's look at some of the things that people have thought about longer than 30 seconds that I gave you come up with. One is a big word called homeostasis. What does that mean? It means it can regulate its own chemistry and temperature. All right, so everybody here has either got glycogen or you got a body that's pretty good at keeping you warm. So I think you're alive. Organization, composed of one or more cells. Okay. Metabolism, converting chemicals into energy. So our breathing, growth, increase in size or parts, and adaptation can change itself. It might be kind of a little bit of the bottom of the screen cut off. You have to have a little bit of the bottom of the screen cut off that projector somehow.
Oh. Why is that?
I don't know. Responses to, it's on the computer screen, so I'll go back. The adaptation is on the computer, but it's not there. Yeah. The projector thing? Yeah.
Must be. I'm not sure that we can do anything about it.
Okay.
Probably just
I think I know what it says.
It's a setting.
Response to stimuli, so with lights or sounds, moisture changes, it does things, all right? And reproduction, it can make more copies of itself. So now let's take a look at those things again. So you guys are still happy with animals being alive? All those things, all right? Plants? Bacteria? Yeah, definitely moving around and stuff. How about viruses? They don't really have a cellular structure though. That's one of the things that they don't do. They don't really respirate. They don't take in energy and metabolism. But they definitely reproduce. And they definitely change over time. So, and then prions, yeah, they don't even have a cellular structure. So, yeah, I think the scientific world is probably someplace right about here.
John, I'm going to try something with the screen,
Sure.
so hold on a sec. See if this does anything. Nothing?
Making me feel blue.
Yes. That looks like it's a little
Yeah,
deeper.
it's all there. Yeah, how about fire? Fire reproduces, it consumes, regulates its temperature within some things. Gas, no. But some people have equated fire to being something like that. All right, definitely not life. So, the nature of life, well, we have chemical processes going on. We have DNA. What does DNA do inside you? Helps you reproduce. It stores the information about who you are. And there's interesting stuff that things that we're made of, proteins and DNA, all curl right-handed or left-handed. And something you'd never hear about in science fiction shows is, well, on Earth, most of the DNA and sugars are right-handed, so it goes this way, curls this way, just like the picture there. And most of the amino acids and enzymes and proteins you eat curl the other way. If you went to another planet, hopped off and picked a piece of fruit, and it was made of little amino acids and sugars that curl the other way, this could be horrible poison. It could actually just dissolve in your mouth. Or it could be absolutely zero nutrients. So you think you're going to be stranded there for a while, you eat a whole bunch of fruit from the trees out there, and you realize, I'm too hungry and I'm losing weight. So that's just a weird little thing about Earth. Earth is very standardized in how its protein, sugars, and like that are constructed.
So how would it, if the DNA was right-handed or left-handed, how would that change whether or not you could metabolize it?
Because that's also based on the sugars and the proteins it produces and the lipids that it makes and everything. It has to be correspondingly curled the correct direction to operate with it. Otherwise, you don't get the proteins created, you don't get reproduction happening. So everything has to have the correct handiness to work. All right, so this guy looks like a good nerdy scientist. Miller decided that he would try to see if he could create the conditions of early Earth with ammonia, methane, atmosphere, and hydrogen, and zap it with electricity and all sorts of stuff like that. And he did get some amino acids and things like that form inside. Didn't get any life, but got the precursor stuff of life to form from those early ingredients. Now we think his mixture was a little off. Wasn't really what our early atmosphere was, but no, I've heard of this has done it with the new hypothesized Earth atmosphere. But someplace way back here, 4.5 billion years ago, the Earth come together, the Earth cools enough for crust to solidify, and very shortly after that, we have evidence of the first life. I mean, it's very quick. It's like everything snaps together and away it goes. We don't know how that snap together and away it go happens. We have no idea from the science what that step is. We have all precursor stuff, we have the stuff after, but that's still a big mystery area. Some of the ideas are that little proteins, little amino acids can get together and sometimes make little spheres, like an early cell. Lipids, fatty molecules can get together and make a circle or a sphere. You can get inside of mud, little gaps and pockets that could serve as a cellular environment for things to get together, but it's a big leap from there to a working cell, which is fantastically complex. These are stromatolites. These are very early bacterial mats. These are in Australia, the oldest fossilized remains of things that were alive. And that goes back 3.5 billion years. There's a close-up of one of these little critters. Not very exciting, but interesting. Now, only 2.5 billion years ago, along came these little creatures, cyanobacteria, that really produced a lot of oxygen. And the Earth's crust rusted when oxygen started to get produced in huge amounts. And when you drive around in the mountains, or you go to Sedona, or Central Australia, or where is it? Red Earth Society in Oklahoma and like that, all the red earth, Precambrian rock, is reddish because of this first oxygen combined with the minerals made iron, oxygen-based minerals. So it reddened the earth, got sucked down, but these little guys kept working and making more. Yes?
Oxygen from where? From what?
I think the oxygen comes from the carbon dioxide, just like it does now. All right, so what was needed for this to occur? Things being just right. And here we get the idea of the Goldilocks zone around stars, that if you get too close to big stars, or even too close to little baby stars, it's too hot. The radiation level's too high, too much heat, period. But there is an area here between that and the coldness of space that you get a nice zone where a planet with an atmosphere similar to ours will have water that's in liquid state some of the time. We are a little bit on the inside of that zone. Mars is outside of it now, cold, and Venus is definitely inside the hot zone there, just on the edge. And over time, our sun will continue to warm up. So it will, this hot zone will expand outward, and in the very, very distant future, billions of years from now, the Earth will be baked to molten lava without oceans or atmosphere by the sun. Now, this is what we think is important for life that's based on water and carbon. There's other possibilities, but we'll take a look at those in just a moment. So from dim stars to hot stars, the habitable zone, or the Goldilocks zone, moves outward. In a galaxy, you also have an area where you're more likely to find everything come together for life. In close to the central bulge where the big black hole is, and there's a lot more crowding, a lot more radiation, a lot more dangerous things happening. Out in the outer edges of the galaxy, there's just less material. Things are farther apart. It's less likely large gas pods will come together and make as many planets. It can certainly happen, but the place most likely to look is this Goldilocks zone around the middle. So what do we need for life? Well, we need probably a liquid, some kind of solvent. We can dissolve things and move things around, some energy flowing, and nutrients of some kind. On Earth, it's water. The sun gives an awful lot of energy for life, but we also get some with hydrothermal vents down the bottom of the oceans. Also hot springs and things like that. And the nutrients that we are largely built on are carbon, nitrogen, oxygen, phosphorus, hydrogen, sulfur. Yeah, most of us probably like temperatures around the 50s to 90s or so, unless you start putting on clothes or coming up with some way to get shelter. But not all life here on Earth is as picky. So let's take a look at these little guys. We call them extremophiles. And as part of searching for life elsewhere in the solar system, scientists started to ask, can we find life in really harsh environments here on the Earth? And they were very surprised at what they found. Now, this is a pretty big one compared to the rest that we're going to look at. This is called a water bear, because it kind of looks like a little bear. Actually moves around a little bit like a bear. But it's about the thickness of a credit card, can survive all the way down 400 degrees below 0 Fahrenheit. And that's below the temperature where oxygen freezes, and can survive all up to 303 degrees Fahrenheit. So these are very tough little guys. Probably have not seen one in real life. But a lot of bacteria starting to be even more rugged than that. Acidophiles can eat sulfur and sulfuric acid, use that for energy. We find these in deep ocean vents, volcanic vents. Halophiles are like salt, very, very extreme salty environments, like the Dead Sea. Thermophiles are happy in very hot, high temperature, scorching environments like geysers. So they give the pretty colors to what you see at Yellowstone Park. Psychrophiles are the opposite. They like the cold, so they can be at high pressure, very cold temperatures, and be happily doing their little bacterial thing. Methanogens, like swamps, trash dumps, and your digestive system. So they make methane as part of what they do, and that's enough said about that. Recently, NASA announced, actually a year ago, this month, the possibility that they found life that can partly live on arsenic. Cellular structure and possibly the DNA can replace phosphorus atoms and put arsenic in there, some percentage. This is very controversial, and it's still being hotly debated in the scientific community. But if this is the case, the same extremeness of what life can do and put up with is important to know. So we'll continue to play with these things and see if they really are made from some other, what to us is a poisonous material. All right, so where might we find life in the solar system? Everyone want to throw some guesses out? Where would you look? If someone gave you a bunch of money, where would you want to go?
Titan.
Titan, all right. Let's go.
Earth.
Earth. I think there might be some. And I think there's also intelligent life because you guys are here.
Europa's Mars.
Europa, that's good. Mars. Okay. All right, so you have Titan, Europa, Mars. Anything else come to mind? Yep, Mars is one. So let's talk about Mars. Nice. Here's another image of Mars. These are big volcanoes over here. This is Valles Marineris, huge canyon cutting across the face of Mars. You can put New York about here and LA about here. It's about 5 miles deep at its deepest, 5 times deeper than the Grand Canyon. A big canyon. Not very big planet though. Fourth planet from the sun. Temperatures can be pretty nice. You can get about 74 degrees Fahrenheit at noon at the equator. You can take off your spacesuit for a moment, except for really low pressure, that's a problem. But in the winter, you're down to 200 degrees below, so very cold. You have ice at the poles, carbon dioxide ice, and water ice. And we've recently found large amounts of ice underneath the surface in the polar regions, and hints of it closer to the equator. So there's a lot of water there. Here's some frost in the morning, taken from Viking. Here's pictures of channels. Some of them look like they may have been cut by one titanic event, like a huge release of water, but some of them look like more what we see with streams and rivers here on Earth. We get a lot of rain happen for a while, and water collected and made these little channels that eventually met. More recently, we see closer to the equator evidence of water, maybe even now, coming out of strata at the edge of craters. This is probably extremely salty, briny, gooey water, but it looks like water, and it darkens and it leaves behind a whitish, dried remains evaporate. That's what we're looking for. But Mars might be self-sterilizing. They have peroxides made of iron and minerals at the on the surface of the planet. So just like hydrogen peroxide can kill germs on your booze, this stuff can do that there. They have a lot of ultraviolet radiation. There's no ozone layer like we have. But still, with water under the surface, we could have microbial life still happily living down below the crust. We have found microbes on Earth, I think down to 2 to 3 kilometers. So you're around 2 miles or so into the Earth. It's very high pressure, higher temperature, but they're happy under there. We do have from further back another controversial NASA announcement where these possible fossilized microbes in a meteor that was picked up on the Antarctic ice sheet. And you know, if you're walking around on a few miles of ice and you find a rock in the middle, it probably came from above. So that's graduate students go out there in the summer and they go around and pick up whatever rocks, and you're getting pristine, very recent fall, hopefully, rocks from space. This has the right chemical composition, iron content, gas stuff in little nodules inside to match Mars. So they're confident this came from it, and electron microscope image shows these little guys here. But they're way too tiny. It'd be like having a normal adult human being with functioning organs and brain, everything fine, is less than an inch tall. And as far as we know, we don't have room to put all it takes to be a person into something that small and adult. And same thing with microbes, bacteria, that small is not in our experience. Just in the last few weeks, we did get an announcement of gypsum on Mars near the Endeavour crater. This is taken by the Curiosity rover, and this gypsum, you know, a picture of it here, this is only a few finger widths wide, so this is a picture right here on the ground, and that has to form where water flowed through rock. So we have more and more evidence, as if we didn't have enough, that there's been a lot of Mars water in the past. So More to come on Mars. We just keep sending things there, making more and more measurements. We got the new monster rover that's taking there to make more water and precursor life measurements. All right, so let's go out to Jupiter. And somebody mentioned Europa. Now this is outside of the habitable zone. We're out where it's very cold. But Io here in Europa, this is the actual line of the planets did this, not some clever Photoshop here, are two moons where we could find life. So first we'll look at Europa. When you're seeing Europa, you're seeing a big ice ball. You're seeing pretty much a solid, pure ice crust. The yellowish stuff actually is sulfur compounds from Io. Io has a lot of volcanoes. And so it lands here. It could be food or something. But lots of cracks, lots of fissures in the ice here. It's Jupiter's third largest moon. And what we think is happening, and it's even more extreme on Io, is that as the moon goes around Jupiter in a tremendous gravitational field, the moon is squeezing, 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 squeezing. And that generates a tremendous amount of heat inside the moon. So where we might find, with heat and nutrients, maybe near hydrothermal vents at the surface, we could find life. So we think there's a solid interior, you got a core, this is very hot, you got a liquid, melted ocean sandwich underneath, crust of ice, and then vacuum of space above that. So that is a possible place to go. Problem is, you got to drill through all this ice, get a sample of that water to see what's going on. We're on a submersible that can swim around and with the big lights and try to take pictures. And if you got there and it was all cloudy, then your cameras don't work at all. So there's a lot of risk in going there. Now, how do you get a signal from underwater, under ice, out to a spacecraft and back to Earth? Pretty hard. That's a pretty hard mission. Io looks like pizza. It's even more violently squeezed and heated from the inside. And all around it there are volcanoes, old volcanoes, new volcanoes, almost no craters at all because the surface gets remade very, very frequently on a planetary cosmic scale. Very thin sulfur dioxide atmosphere, but you have complex chemistry that could be useful to life, lots of hot and warm locations, but also a lot of radiation from Jupiter, radiation belts around it. Those are very hard on the instruments we send up there too. They weighted taking, say the outer moons first when they send things like the Galileo probe there, and then they get closer to Io because they may lose the spacecraft when they get in that close. It's a very violent volcanic environment with plumes of material being thrown up into space and very little water. So maybe, but it's pretty extreme. Yes?
Where's the radiation coming from?
Radiation is similar to the Van Allen belts on Earth, and it's the magnetic field of the planet interacting with these solar charged particles, the solar wind. So you get an acceleration of those particles trapped and funneling around, and just a lot of radiation. Right, Saturn system. Nice picture. You can see the shadow of the planet on the rings there. And here's one that nobody mentioned. The moon Enceladus, or Enceladus, I don't know the favorite pronunciation of it. But again, look at that. An awful lot of ice. Very pure ice. We do have some craters though. We just have some very old surface, but we have some surface here without craters and lots of cracks. And what this is the sixth largest moon of Saturn, 99% water ice surface. Cassini probe detected carbon, hydrogen, nitrogen, oxygen coming out of large geyser fissures that were not expected at the South Pole of the moon. So it flew through there and picked up a hint of stuff. We would like to go there and see what else might be in that spray coming out. Because you don't have to drill through the ice. It's the stuff that's in this sub-ice ocean, if there is, and we think there very strongly is, tidal heating again, it would be spewing Enceladus bacteria at us, maybe. That would be really nice to know. Titan, somebody mentioned. And here's what Titan would look like if you just went visiting. Here it is with infrared eyes. You can kind of see through this haze. The nitrogen atmosphere with a lot of methane and other organic compounds. Saturn's largest moon. You have the triple point of methane. Now here we have the triple point because like right now there's water vapor in the air. Today when it got a little warmer there was some water running in people's gutters because not all the gutters are frozen or melted yet. And we have frozen ice out there still too. So we have all three phases of water just around us right now, and methane is found in that on a much colder moon here. But we're talking really cold temperatures, so water would be like rock or steel. You could build things or have very long-lasting mountains of water at this very cold, low temperature. We dropped a probe down in there, Huygens probe, and it took pictures on the way down, and you see what looks like river channels. Here's a picture from the surface, kind of smooth, pebbly rocklet things. Those rocks could be just water, rocks. Kind of a weird thing to think about. Here's some pictures of clouds that seem to form, methane clouds. Here's a spot that may have filled up with methane liquid, like a lake. All right, so if I gave every one of you $10 million, which has not happened, where would you want to go? Which of these locations do you think is most likely to find life? Can't go over budget. Mars? Well, Mars here. Mars would be closest, yeah.
Well, that has money you can get.
Oh, you might be able to get a probe going out there. Yeah, Mars would be good, except again, that surface may be self-sterilizing. There may not be a lot to find there. I think if you just sent something out there to Enceladus to fly through the geyser and take a scoop of that and analyze it as it goes by, you wouldn't have to land, you wouldn't have to do anything else. Enceladus would probably be the best hunting spot for a first just looking for life type probe. That's my opinion. All right. So the Goldilocks zone of planets is maybe too limiting. So we've seen we have life at hydrothermal vents at the bottom of oceans. So all these watery moons that have some heat source are a good place to look. So wherever you have chemical energy available, you could have critters going. Alright, so when we're looking at planets many light years away, sending a probe is not going to work. Or you don't have to use the light that comes to us. So if we could get information, just looking at the light, of the chemical makeup of atmosphere of other planets, if we look for things that don't stay around by themselves for very long, like oxygen, all the oxygen you're breathing came from green plants and life. So if we found oxygen around another planet, we would be able to go thumbs up, we almost certainly have life. Methane is another good one, except on Mars we do have a hint of methane in that carbon dioxide atmosphere. Could be life, like it is here, or could be something from volcanism, or it could even be an iron oxide converting to a mineral that can do that. Since we know something else about Mars's composition, methane is not the best sign for life. So we have just within 10 light years, 15 light years or so, we have about 25 stars we could get a pretty good image of. Within 250 light years, we're up to about 260,000 stars, but now it's being very hard to get, with present-day technology, to get images or information for anything but these stars themselves. And in our galaxy, of course, we have billions of stars, but those are often very difficult, distant and difficult to look at. So. And could be an awful lot of life in the galaxies around us, but now we're even 8 orders of magnitude harder to detect anything. So we're looking at our neighborhood. We're looking at stars nearby first. Check Observatory, Look Observatory, Anglo-Australian, and the Magellan Telescope are all participating in the search for planets out there. We call them extrasolar planets or exoplanets. As of May 2008, we only had under 300, but as of tonight, we have 710. Kepler has over 1,200 candidates. And if you have a smartphone and you really want to know where we are on exoplanets, there's an app called Exoplanet, an app called Kepler that you can get. I think it is a couple dollars. And you can download every day. You wake up in the middle of the night and check how many planets there are suspected. So most of these are massive gas giants so far because those are the easiest things to see. Here's 5 planets in this system, the 55 Cancri system between 95 and 2005. There's where Earth is, there's where Jupiter is in our solar system. They got some big giants in close and one way out there. So it's they kind of like us, just different. Down through the years, we have had candidates or good discoveries increasing as technology has gotten better and better. 2008 took a little bit, but if you pull back to see 2011 with Kepler mission and even more money going into planet searching and better techniques, we're really hitting some big numbers now. So let's take a look at just a few of these. One that was announced a little earlier on was just 20 light years away, called Gliese 5A1c. It was at the time the closest in size to the Earth, and just barely in its system's habitable zone. It's in the constellation of Lyra, but it's around a very cool, dim class star. It's about half, again, larger than Earth, so gravity would be about 2.25 times more. So if you're losing weight before the holidays, you'd instantly weigh more than twice what you do now just going there. So not the place you want to go. But here's an artist's conception of what that system might look like. If it's an icy water planet, it may be less dense, so its gravity could be less. But its year is only 13 Earth days long, so it's very close to its sun, the very dim sun, and it's zipping around very quickly. So we believe that one face is always going to be pointing towards its star, the way our moon has one face always pointing to us, and that's probably its comparison size. And an artist's conception of what it might look like, with the sun always shining here, permanent twilight here, permanent darkness that side. So you might have liquid water, storms and things here, an area where fronts and some rain spreads out, and you got a place where it snows an awful lot of the time, and then solid ice in the back. So kind of interesting place. Maybe the nicest places to live would be sort of in this temperate zone here with the sun lower in the sky. But,
so if you've got that type of situation, you have water migrating towards the back of the planet.
yes.
Away from the front. So you
could have that freezing and
so would that be enough to maybe change the center of gravity? That would actually.
Well, you probably imagine eventually you get glacial moving back into the flight. I was at AGU last week in San Francisco, and I was in the planetary sessions there. They actually modeled all water planet in a way that Europa and Enceladus are. And they showed that once you get melting here, the melting actually would spread all the way around the equatorial region, even into the dark part. I thought that was pretty surprising, but yeah. Another one with a very cumbersome name. I'm not going to rattle all that off, but it's near Earth size. It's got some problems though. Here's an artist's picture of it. It's 21,000 light years away, so it's much harder to get to. It's very far from its dim star, 2 to 4 times further than our planet is. And it's 5 times Earth's mass, 10 Earth years long. Because it's so far up from such a dim, cool star, it's really cold. So, not as likely a place to go. So let's talk briefly about the Kepler mission. Kepler is a spacecraft that is staring one part of the sky, looking for planets. Its depth is roughly 3,000 light years out from us. It's looking at a very small part of the sky near the constellation Cygnus. There's a little field that it's examining. And there's a picture of that, of what it sees. And it's constantly looking for planets that are going in front of the star, making the star momentarily dimmer. And just in the news, I had to include this, was Kepler 22b. Now that's found, as I showed, over 1,000 candidates planets. Most of them are very big, but this one is maybe only 2.5 times larger than Earth. Its year is very similar to ours, 290 Earth days long, and very similar star, rather than a dim M-type star like these earlier examples here. So it's in the vertical zone, comparing our solar system to the Kepler 22 system. You can see it's just a little bit closer in than ours. So this is a really good first hit for a possible water, right temperature, right place, right kind of star, similar to us. So we're going to hear a lot more careful research done on this. All right, so that's as far as I can take you for habitable planets. So let's talk about jumping past knowing what the planets are. Let's see if we can just find intelligent life. So what is intelligent life? How would we know that they're out there? Listen. Okay. How would you do that? Radio, okay? Yeah. But 1,000 years ago, would aliens have known about humans? We had an awful lot of civilization going on. We had lots of writing and cities and wars and things like that happening, but nobody out there would have known about it. So yeah, smoke signals and telegraph, not there yet. Once we get radio, television, radar, microwave transmissions, not microwave in your kitchen. Think about that until now. Yes, now the universe could hear about us. What about when we switch to cable, internet, and laser communications? Are we easier to find or not?
Same.
Saying, but some of what we're doing is now being shielded and kept down near the Earth. With bandwidth limitations hitting, we're starting to radiate less in some ways. I mean, TV has now gone to digital. It's very different than it used to. But communication is it, and the speed of light, okay, is the limit. So radio signals now roughly 100 years old. Good night. It's demonstrated in 1894 in Oxford, 1906 first transmission played O Holy Night, Christmas Eve, and was heard by ships at sea. After that, more stations started coming on, regular programming was created. TV is now about 80 years old, not 80 odd years out, and bubble around us. 1931 New York City radio station came on. The Olympics, or broadcast in 1936. Who did that? Germany. Ever seen the movie Contact? Yeah, the aliens in that movie got the Hitler channel and sent that back to us and said hi to you too. So clever little plot trick there.
John?
Yes. Question.
Is there any way that we can detect sources of light coming from a planet, like fires or artificial light, or, I mean, it's pretty dim, but...
It's very, very dim, yeah. Current technology, absolutely not. I think that even when you get across the solar system, you have to do some careful stuff to see all the city lights and like that. You could pick up the spectral signature of night.
I mean, well, because we don't burn like the sun does, any light that's coming off the planet, you'd have to wonder where it's coming from, right?
Right. The reflectivity off the day side would be very dominant. But you would have a little signal. But I don't think that when you get to interstellar distances, you'd have to have some pretty serious technology. I don't know how you can do it. Just guessing. Yeah.
About the speed of light, which you seem to be
speed limit of the universe.
Yes.
However, there are neutrinos,
Yeah,
that are
yes,
very
sir.
close to that, and some recent, scientists have claimed that maybe neutrinos will run faster than light.
Right. That is a study where they're throwing, I think, protons out into the Earth's crust from CERN. Those are interacting and creating neutron blasts that are being measured. I don't remember how far away, 150, 200 miles away, something like that. And yeah, they're like 60 microseconds faster than they should be. The pulses are getting there quicker. One of the big problems with that is one of the great successes in neutrino astronomy was detecting the blast of neutrinos that came from supernova in 1987A from the Large Magellanic Cloud. And that burst came just a few hours before the supernova went off, and neutrino astronomy was in its infancy, and two different detectors, one in Japan, one in the US, I think, picked that pulse up and went, hey, we just saw something in the sky. If the neutrinos were coming that much quicker, if they were, the pulse would have arrived 4 years earlier. And so that doesn't match that observation. But there have been other, well, there's one other observation, I think in the US, in an old gold mine or something, that hinted at the same advance, slight increase in speed over the speed of light. So other problems with the neutrinos would rapidly lose the energy and be back to the speed of light, sort of a Cherenkov radiation, where electrons go faster than the speed of light in water. In a nuclear power plant, you get a bluish glow. That's the loss of energy in electromagnetic radiation. These little particles the electrons are slowed down. So we don't see that either, though. We don't see that happening. So it is a big mystery right now, but I wouldn't throw the speed of light to the curb yet. So I think they've got to make a lot more careful checks. So there's a big team of people working on it, but I think they just check the whole thing a lot more. So, yeah.
Yeah, I have a question. I got a real problem with the speed of light.
Okay.
And I want to know what you think about that being the speed limit, the cosmic speed limit. Because if the speed of light is the limit, probably there is nothing else visiting us or doing anything.
Right.
What do you think about?
Yeah, with the speed
Can we bend the rules?
The only way to bend the rules is to play with concepts like wormholes and like that. And best of my knowledge, I mean, physics kind of leads.
Tough question, huh?
Yeah, it leads you some avenues for wormholes, but you have to have something like negative energy that you can wrap around to hold the mouth of the thing open. Otherwise, you can make wormholes so they close much faster than anything can get in and through, so information doesn't get to transfer.
Yeah.
Yeah.
What do you think? Can you bend the rules or not?
Can you bend the rules?
You.
Well, definitely not now in our current physical understanding, but maybe in the future there could be some breakthrough in how extreme environments physics works out in. We don't have a theory for quantum gravity yet. We can't handle singularities and things like that in physics. So there's room out there, but nothing strong that says yes and maybe we will.
Okay. Toughest question of the night, Rick.
Oh, that's okay. I didn't want to get too far off on the side either, but so as far as we know, speed of light is the limit, and yes, that does make it very hard to get alien life here or us to other stars or planets. So SETI, the search for extraterrestrial intelligence, we were talking about that a little bit earlier, listens to the 21 centimeter line of neutral hydrogen and 18 centimeter line of oxygen hydroxide. First is the Green Bank Radio Telescope. On a cool, clear, windless night, the telescope was motionless. The operator stepped out with his coffee, took a few drinks, stepped back inside and sat down, and the ground rumbled a little bit, and this coffee shook, and he looked out, and that beautiful telescope had become that. So, it was in 1988. It was a metal piece, critical, that just metal fatigued and failed. A girder hit and pitted into the ground right where he had been standing for a few moments. He was fine, just shaken up a little bit. So they rebuilt it. It's bigger and better than ever. It's inside the U.S. National Radio Quiet Zone. Also, the Arecibo Observatory. You've seen this in the movie Contact, or was it Goldeneye or Goldfinger? James Bond. Yeah, James Bond. He had to go. He had Jaws and Bond up there fighting it out over the dish there. But there they've taken a whole little natural valley and turned it into a 300 plus meter radio telescope dish. It can point a little bit by moving the collector horns there around, but you can't point it. You have to let the Earth really do the pointing of this thing. But they listen here and collect static from space, looking to see if we can find TV or radio or radar or something like that from out there. It was first proposed to listen way back in 1955. 1963, the Big Ear project was on. NASA funded briefly Project Cyclops, which is a bizarre name, 1971. In 1977, the WOW signal, this is you kids out there, before computer monitors came around, we had paper, we printed numbers out. So ones and threes were not much, and blank was nothing, but here we're going from 5 up to U in the alphabet and back down. So the operator circled that and said, wow. It was never found again. We've gone back and listened and listened and listened to it. Of course, you gotta take into account spy satellites from other countries and our country going over the installation, things like that. But and the constellation Sagittarius below one certain star, but we've not seen anything from the WOW location in the sky since. And who speaks to Earth? Or what if we do get the signal and we decide to, say hi back? Send a little thing. I mean, what country might they first be discovered by, and how they respond? We have really little agreement out there. There's a SETI Declaration of Principles that says that until we figure out how to respond, nobody says anything, but nobody has to stick to that either. So, or was it UFO abductees who have it the first contact? Probably not. In 74, we did broadcast a message out, which is oddly towards N13, 25,000 light years away. Wouldn't you send that to some close stars? But they sent this through Arecibo. They taught the aliens how to count up at the top there, binary numbers. Then they put the atomic numbers of what we're made of, hydrogen, carbon, nitrogen, phosphorus, in there. Formulas for sugars in base DNA. Picture of the double helix. The number of units in DNA, picture of what we look like with 2 arms and 2 legs, a population of Earth at that time, the planets. Of course, they had Pluto in here, and Pluto's out, so we'll have to update the signal. With a little third planet from the sun tilted towards us, showing that it's us. Here's the Arecibo dish and its wavelengths. And they broadcast for a little while, then I guess a congressman got wind of it, said, wait, you're telling them where we are, what we're made of, and how to poison us? Stop! So they turned that off, and that has not been done since. I know. Because the question is, are they really going to be nice? Or maybe to spread across the universe, there would have to be a peaceful galactic club out there. Who knows? Interesting thing, going back to the handedness of proteins and sugars, what if their handedness was opposite of ours? Well, we couldn't go to their planets and have food. In fact, just breathing pollen in their air might hit our lungs like asbestos or something. So maybe that we would have to divvy up all the planets in the galaxy, and the ones with the right handedness for us we get, and the ones handedness for them they get. I don't know. So that's a problem way off in the future. So modern SETI, we are searching since '79 multiple versions, but the biggest one running right now is SETI at home. They use the Arecibo telescope to pull in static. They break it up in little packets, and they send it out to your home computer. You download a little program called Boink now, and takes a piece, looks for signals, sends it back, and asks for another little piece. Multiple computers work on the same pieces, and they put it all together. 234 countries. I tried to update this today. There's 5.3 million computers, they say, are working on it. 19 billion computer hours. I couldn't find a new number for that, so it's not much higher. It was at that time the second fastest supercomputer on the planet, and now we have many faster. But also building the Allen Telescope Array in California to try to add to this search. You can help if you go to setiathome.ssl.berkeley.edu or just Google SETI at home. You can download it and contribute your computer's idle time when you're not playing games and like that to searching for aliens. This is what your screensaver will look like, and you can actually see the data being processed on the computer. And there's people contesting each other to be one who's contributed more than anybody else. The Allen Array in California will be able to do a lot of good radio astronomy at the same time that it's searching for signals from out there. That's what it hopes to be someday. Here's the first dishes going up. I need a new battery. Funding did run out in April, just because California is having budget problems like everybody else. They did find short-term funding in August, and they just went back into operation 11 days ago. So, future of SETI, we're going to look for laser signals, optical SETI at the Lick Observatory. Frank Drake said that this will be one of the more sensitive types of searches. We're going to talk about Drake in just a moment at the end. But they're looking to see if, we may go to laser communications, maybe between planets. You have a solar system internet someday. The lasers might be picked up, or they could be signals sent directly at us if they think we're here, because they saw oxygen in our atmosphere. So they're searching about 300 individual star systems, trying to do it on a weekly basis, looking for little laser pulses. Of course, we also sent a signal out on the Voyager spacecraft gold records, because records will never go out of style. Aliens will definitely have LP record players, but there's instructions on that. And they're getting out really far now. Voyager 1 is out at the edge of the solar environment and interstellar space. But it's going to take 40,000 years before they even get close to another star, so that's a very slow email. So Frank Drake came up with this way to estimate how many intelligent beings there might be out there to look at. And you just multiply all these probabilities together to figure this out or estimate this. And I've got year 2000 estimation numbers there and year 2008 estimation numbers. Numbers of the stars of the galaxy, we've got that pretty well estimated. Probability that a star has planets, it's looking a lot more likely now than we thought then. Probability that a star, probably number of planets in the life zone, kind of small number, but they're out there. Probability life will originate is a big guess. Probability life will become intelligent, even a bigger guess. And the fraction of the star's life as civilization is communicative. It actually uses radio. And what if they're dolphins? Smart dolphins in the ocean world, where they build antennas and have radio and television? You're not supposed to put your television in the water. But even here on Earth, we've had numerous disasters through time that has knocked life back on its heels. We've lost well over 99.9% of the species that have ever come about. So it's a dangerous place. But putting all these numbers together, back then they had a huge range that you can, using more recent guesses, maybe 2 civilizations in our galaxy that would be communicating. But you're free to make your own numbers up and multiply that out yourself.
And that was within our lifetime of us being able to listen to it.
Yeah, it really doesn't have a slant on that either. I mean, they could have come and gone already and done their thing, and the signal might get to us, but they're gone. No. But yeah, lots of hazards in our galaxy, making it a dangerous place to live. So we are going to keep looking for Earth-like life and non-Earth-like life as best we can in our solar system and in the stars around us. And to quote Ellie Arroway from the movie Contact, if it's just us, it seems like an awful waste of space. Questions? Yes?
I've read that in Miller's experiments, even though he made amino acids, they were extremely unstable, and they immediately disintegrated almost as fast as they were made.
Yep, and I don't think they have the same bias for handedness.
No, they were
Yeah.
right in left-handed.
Yep.
And they
So
were-
that's not good either.
Yeah.
So yeah, there's an awful lot of unknown right there.
But
Unknown around us.
nothing like life. And besides, this is a controlled environment as opposed to the water and the ocean and something.
We do see amino acids from meteorites, and there is a preferential handedness that matches Earth in the ones that come here. So that might be a solar system thing rather than just an Earth thing. But why, we do not know. Yes?
I have a question about Mars. Mars is basically trash because it has no magnetosphere.
Yeah,
There's
very weak,
right.
yeah, so there's no protection.
Yeah, there's no protection. So
And
why are we
no ozone
bothering?
layers because of
Why are we bothering to do all this work? Because I keep hearing terraforming Mars.
Yeah.
Why?
Yeah.
If there's no magnetosphere to protect it, what's keeping?
Right, you could probably, I mean, much further down the road when we have a lot more energy to play with as a civilization, whatever it is that we play with and work with, you could conceive of steering comets in, slamming them into Mars for 1,000 years or so, and really build the water
Right.
up and build an atmosphere up and like that. But you're right, it doesn't, it's much smaller. I think the dry surface area is equal to the dry surface area of Earth.
Right.
So we have that much more space just in oceans. So it,
How can we fix the magnetosphere? Why do we bother? You can't.
right, you can't,
Okay, all right.
you can't get the dynamo going again that we know of inside of Mars.
Okay.
Well, couldn't you be underground and protect yourself from the radiation?
Absolutely. With the volcanoes there probably are similar to the moon, lots of lava tubes that one could use as a natural thing, because you don't want any Mars quakes or moon quakes to happen and destroy your habitat. But yeah, there are ways to go underground and be safe from a lot of that, micrometeorites and things like that on the moon. So. Other thoughts or questions?
And then you got to know vitamin D.
Yeah, you need some UV on your skin and make vitamin D, absolutely. All right, well, thank you very much. Just because I did a substitute for this week, next week was the real one that I was planning for the last few months. So Star of Bethlehem will be same time, same channel, same room, very different topic.
So we'll have the telescope open again, it's still very clear outside, so if you guys want to look at some objects, I don't know if we have some volunteers that can go up to run the telescopes.
And Mike will give tours over here at the disco.
Yes, if people want to see a 24-inch, certainly do that.
Can't look through it, you can just see the history.
See the history here. John, turn the projector on.
I think the evidence is very, very strong.
Gold here.